Okay, let's look at some more of the questions that came up as we are doing that last example involving a union type. The first thing I just want to remind is that, hey, we did follow all the steps of the design recipe. Well, all the steps 4, 5, and 7, and 8. Okay. If you're really bothered by that, don't worry. This video, we're going to add steps 1, 2, and 3a. So, okay. So we'd had this data type lookup-result, and we said it was one of these, a username, or the Boolean false, or the symbol tick private. And that or, it can be one of these, or one of these, or one of these. This is a union type with 3 variants, okay? So, and we went ahead and wrote some code. I guess the first thing is this cond that we saw. Let's just go and look at the... we saw an example of cond, and let me just talk about the syntax of cond. Okay, so do that down here, I guess. The way cond is written, we say open paren, cond, and cond is again, it's like an if-else-if. It's not quite a function, and we're going to have a bunch of question-answer pairs. So I'll have a question-answer pair, and maybe another question-answer pair, and maybe another question-answer pair, and maybe a fourth one if I need it, or a fifth one, or a sixth one, and then I'll close off. And the question, what does the question have to be? Our example, we saw it was like string question mark of ALR, or Boolean, or symbol of ALR, and often for handling union types that's the case, but for a general if-else-if, it can be any expression whatsoever. Give me any expression as long as it evaluates to a Boolean. So, give me any expression for the questions. And similarly for the answer, well, same thing. The answer can be any expression you like. So we actually have the syntax for cond. In fact, I guess I'll go ahead and say ... That would be the syntax for cond. ... meaning 0 or more of the following things, or preceding things. So a cond expression is an open paren. Cond, you must have an open paren, you must have a COND, you must have a square bracket. I'll use angle brackets this time. If I'm on the board, I'd use a different color marker to say, hey, this angle bracket don't type in angle bracket and don't type in EXPR. Type in some particular expression. Okay, so that's the syntax of cond, and it's an if-else-if. What are the semantics? Well, the semantics are if it's an if-else-if. Racket will come along and evaluate the first condition. If that first condition is true, it will evaluate this as the answer. Otherwise, it will ignore that first answer, look at the second condition. If that condition is true, it will take the second answer, and so on. I guess if you want to be technical, you can end with... so Racket will keep going until it finds a true condition. It's an error, by the way, to fall off the end of the cond. That will trigger an error. If you want a catch-all, if you want an else at the end, how would you go ahead and do that? What expression might you use? Oops. What expression might you use to make sure you don't fall off the end that's sort of a catch-all? Can you go ahead and pause and think about it? Yeah, you could just say true. Okay, so you might have, I could go ahead up here even, and here's something that I might do. True. And I might, in this case, I might return, whoa, something went wrong. In fact, I will often write this in my code, to this extent. I guess technically, if you really care, you can go ahead and there's a function called error. And you give the name of the function along with an error message. So this actually raises an exception. You don't need to raise an exception. If you want to be a defensive programmer, yeah, put in a default, even if you know it should not be reached, okay? And that's fine. You do that in your Java code as well. And if it should be reached, this might be an answer that gives actual information. So here's another example where this question was not really calling a function. It doesn't have to be calling a function. Just any expression that involves evaluates through a Boolean will work, and hash true is one of them. It turns out there is a special keyword they've added that's only valid inside a cond, and that's else. So if you want to go ahead and write that with else being there, feel free. In fact, that's the idiomatic racket way of doing it. They added that keyword, and that lets the programmer know. That also actually lets the language know that nothing should follow it. If you have an else, it has to be the last thing. Whereas if I just have hash true, gosh, racket, the language doesn't really care, and I could have more stuff going on here, greater than 2, 3, etc. And it wouldn't be a problem. If I say else, then the language says, hey, you can't have any other cond branches after an else. So, okay. You don't need to have this for our class. You don't need that else branch. Again, it already is an error if you fall off the end of the cond. So, at least in student racket. In full racket, it's not, and I wish it were, because I want that behavior. I never want to fall off the end of my cond. If I do, I've done something wrong, and I want to know about it right away. Okay. So, let me go back to, oops, to undo, not redo. Get back to where we were. Okay. So that is our syntax of cond. If you look at some of the questions that we asked here in particular, sometimes people kind of wonder, like, okay, you asked, we know that our type, let me go in here, we had a lookup result is either a username or false or the symbol private. And they said, hey, you just ask if it's any string. Well, what, don't we need to check that it's a valid username? Remember, username was actually a type we'd mentioned earlier, saying, hey, a username is a string with a certain format to it. Yeah, if you want to check that, great. But again, look at my precondition for this function. The type coming in has to be a lookup result. And my philosophy is, if somebody violates the precondition, not my fault. My code doesn't have to worry about that. I'm going to assume you're handing me a valid lookup result. And if you don't, all bets are off. If you don't hand me a valid lookup result, well, if you do hand me a valid lookup result, then I can infer that, hey, if it's a string, it has to be a username, a string of that format. And I can assume it's of that format. Okay. Similarly, for the second question here, I asked Boolean of ALR, and you're like, well, shouldn't you ask if that's the particular Boolean false? What if they pass in true? If they passed in true, they didn't pass me a lookup result. Read the definition of lookup result. So again, that would be violating the precondition, and so I'm not required to worry about that. And similarly here. Now, one thing I might do, you might sort of say, hey, can't I go ahead and ask, if you want to be more precise, sure, go ahead and ask Boolean equal of ALR and hash false. Yeah, you could do that. It turns out in this case, that's going to be a little bit problematic. Why? If somebody passes you a string, you'll catch it right here. If they pass you false, you'll catch it right here. If they passed you a symbol, what will it do? It will go ahead and ask if string, somebody passes you tick private, passes this function tick private, string of private, and you can try it out. String takes in anything and returns a Boolean. Boolean equal, though, doesn't take in any two values. It has to be given two Booleans, okay? And so, gosh, people often want to write this, and yeah, more power to you. That's a great thing to write, Boolean equal of ALR and false. But the problem is now, and similarly, they might want to go ahead, symbol equal of this and tick private. Gosh, yeah, now we kind of have a problem in that you can say, hey, well, maybe I'll put that Boolean to the end. But again, I'm going to have the same problem with, hey, if somebody passes in a Boolean, symbol equal question mark is going to complain. The signature of symbol equal question mark requires two symbols. What's one way you can get around this? One way is to go ahead and put an and. Symbol of A-LR. There, if you want to go ahead and do that, that's good. That's good solid code. My condition is a symbol and it's the particular symbol private. At this point, remember how and short circuits. If it's not a symbol at all, if it's a Boolean, say, then yeah, I'm not going to go ahead and try running symbol equal question mark on it. So this is good and a little bit more defensive programming than just checking, is it any symbol in the world? And if it is a symbol, I'll assume it's tick private. Again, for this class, go either way. I tend to stay with just asking, is it a symbol, is it a Boolean? And that gets the idea across for pedagogic purposes. If you're working for a company, you probably want to do a bunch more code. In fact, if you're working for a company, you might want a whole precondition that this really was a lookup result that you verify coming into the code automatically, and that can be done. I'll post something about that later. Okay, so yeah, we can do that. But again, I'm just happy if you happen to say Boolean question mark or false. By the way, don't confuse Boolean equal with Boolean. Yeah, Boolean equal takes in two Booleans and says yes or no, they're the same. Boolean takes in one value, could be anything, and says yes or no, it's a Boolean. And similarly, string and string equal are very different functions, even though they're spelled very similarly in Racket. So just be aware of that. And I guess actually one last thing, it turns out, here's a little very specific Racket thing. Don't worry about this. Plug ears if you don't want to learn, if you want to learn just the concepts without the direct of a particular language. It turns out there's a function called false that takes in anything and says, hey, is it the value false? And it's just a handy thing to have built in. Now you might say, hey, is there a function called true? That's not built into the language. In full Racket, anything not false is true. Even Booleans in a non-Booleans in a Boolean context can be called true-ish or false-ish. Well, true-ish. False is false. Okay, so I'm going to go ahead and leave it with, leave my code looking like something like that. I'm not too concerned about which of these versions you use. I'm all happy with them. So that's the syntax of con. That's a note on the particular questions we asked and different things you might have that are just as good or maybe a bit more good defensive programming. So you'll get full credit for doing things not the defensive programming way, but it might save you a lot of your own time and sanity to add a few extra checks if it's convenient. So let's go ahead and think about writing another function involving this type, lookup result. So maybe I've gone and tried to make a query of a database and I get back the result, the lookup result. So I'm processing the lookup result. Say I just want to know, hey, is it really a student? So known student of, if it's a username, I want to say true. And if it's, if I get back false or tick private, I'd want to get back, is it a known student? So is there a student by this name? And I'll either get back their username or I'll get back tick private, meaning yes, they're a valid student, but no, they don't want their username given out. Okay, so I can do that. Here would be the test cases. How do we start writing that function? So go ahead and think about it for a second. Pause. Unpause now. Oh, if you're paused, you didn't hear me say unpause. Unpause. There. Yeah, hey, it's going to be, we had a code like this. Is a lot of your code going to be the same? Yeah, you're going to define your function known student, take in something, and it's going to be a cond with how many branches? 3, because you have 3 things you need to process, okay? So, in fact, here, I'm going to give you another question. I write a function that takes in a lookup result and goes ahead and returns the... Can you write that code for me? Well, you didn't even hear exactly what I wanted, or you don't even know exactly what I want the code to do. But knowing that it takes in a lookup result, you can write a bunch of the code. In fact, earlier I said, hey, we're going to go and I saved some of the code that I wrote the cond before I put in the answer. And where did I put that exactly? Put it up higher. There we are. Okay. And so this code I have here, the top of the window, yeah, any function that takes in a lookup result. In fact, I'm going to go ahead and call it func for lookup result is going to look like this. Okay, and I might even go ahead and well, I'm going to go ahead and have a specific term for this bit of code here, the template. This is the template for lookup result. What do I mean by the template? It's the amount of code you can write, having no idea what the function is supposed to return, but knowing what type its input is. Okay, so if you have a union type with 3 branches, you know right away you can start writing the template for this function. Hey, I'm going to have a cond with 3 branches. If you have a union type with 7 branches, you can say, hey, I can go ahead and start writing. I don't even know what the code is going to be doing yet, but I can start writing the code. It'll be a cond with 7 branches, and I can look at the definition of the data, what those 7 branches are, to figure out what questions I should be asking. What 7 questions should I be asking in the cond? So, okay. Yeah, and as a matter of fact, if we go and look at, so you could go ahead and write that function. And now if you have this known student, I can copy and paste it. Let me go ahead and copy, paste here. I can take the code for known student. Oops, that wasn't pasting. There we are. There, known student. And I can go ahead and paste in, and I'm like, hey, yeah, if I returned a username, then hash truth, return the Boolean, that was hash false. In fact, this is just my test cases, my check expects. I can undo those. And notice that having that, okay, in this case, the right-hand sides are all kind of trivial, but nonetheless, having stopped and after I defined what my type was, making that little template and setting that aside and copying and pasting it and putting it aside, it's going to save me time for every function I write involving this type. So, so what does that mean? It means let's go ahead and reveal what steps 1, 2, and 3 of the design recipe are, not just 4, 5, 7, and 8. Step 1. So now we're going to back up to any problem you might encounter. You're given some problem domain. How are you going to represent whatever you want to talk about in the real world? How are you going to represent that inside your program? Give me a data definition. Hey, I need to represent a lookup result inside my program, get it passed around. There's 3 things that can happen. It can be, a real username or somebody who wanted their privacy protected, or an invalid request. So, gosh, how do I represent each of those things? And I gave that to you. I gave you the data definition. But in general, in your problems, the first thing you do is, hey, I need to represent a program, and one of the things I need to represent is the temperature outside. Hey, in Java, I'll use a double. In Racket, I might use, just number, the exact rational. Whatever, you'll decide, hey, how will I represent this information in my program? You're doing that all the time. You've been doing that since the first programming you did. And sometimes, here's the new bit, sometimes it might be a union type. You now have a new sort of tool of ways of representing information. You might say, hey, I want a union type to represent something well. Give examples of the data, okay? And we did that when we went ahead and gave our data definition up earlier. We had our data definition, and the first thing I did was come up with several examples of the data. And why is that kind of handy? First, make sure hey, this really does capture all the information I need. It's a good data representation. And later when I make my test cases, I can just copy and paste some of these things and plug them in as the inputs to my function if I need to grab some. It's like, hey, I need lookup results that span all the different cases. Well, hey, I have 5 of them here. Make sure my code works for those 5. That's an easy way to make my test cases. Okay, so step 1, choose your data definition. How will you I should probably write that down. How will you represent the information in your programming language? And when I say the information, the thing you're modeling, if you're writing an air traffic control system, how will you model all the information that the air traffic controllers need to know? Flight numbers and times and schedules and airports and routes and elevations. If you're writing Pokemon Go, yeah, how will you represent? What data types will you use? When will you use an int? When will you use a double? Maybe you'll use a class. Maybe you'll use a union type if you have a language that lets you use a union type. Okay, and then step number 3, let's give a template. So 3a. If you're handling a union type, go ahead and make the appropriate con with 1 branch per variant, 1 branch per option of your data representation. Okay, and figure out what the questions are, and copy and paste that. Sort of put it up in a comment, set it aside. Then, and you do that once for your data type. Hey, I'm representing lookup result. Steps 1, 2, and 3a. Now I'm going to go and write the function lookup result to string. Do steps 4, 5, 7, 8. Now I'm going to write another function, the known student. Do steps 4, 5, 7, 8. You've already done 1, 2, 3 for lookup result. You don't need to repeat those. So, okay, that is the template. We'll be adding a 3b and a 3c later. So rats. We don't have all of 3, but we're getting there. We're filling in the steps. And number 6 we'll come back to pretty soon. Okay, and now I just want to step back a little bit more philosophically, perhaps. Looking at this, our definition for a lookup result, our data definition. By the way, I went ahead and put the data definition in comments, but that does not mean it was unofficial. I'm just going to remind you, I said this before. When I said, a lookup result is, their data definition, lookup result is, think of that as a real data definition that I can now use the term lookup result as a technical term in my program. So I can use it as the input type in a signature or the result type of a signature. So, you might look at this particular union type, lookup result, and you're like, well, gosh, really what this is, hey, I have an answer, a string, and then I have 2 special sentinel values, 2 special singleton sentinel values. If you're in Java, and say you have a function that returns a string or 1 special sentinel result saying, hey, there is no answer. Or maybe you return an int and some special sentinel result saying there is no answer. What would be an example? Look something up in a Java util map, a hash table. You either return the associated key or you return a special value saying, hey, this value was not in the collection, was not in the hash table. What type do you use in Java for that? Probably use null. Null is your singleton value. So you might often have functions that either return string or null. And in fact, in Java, remember I would say a language shapes how you write your programs. You probably didn't use union types and you avoided things that have 2 sentinel values, but you might have things that had with 2 sentinel values. But if you have 1 sentinel value, then you say, hey, I'll do that in Java, and I'll just use string or null. Why? Null types checks as a string. Null type checks as a scanner. Null type checks as a capital D double. Null type checks as everything. You're throwing type checking out the window if you use null and are passing it around. And when we're either saying, hey, it's either a string or a special value, meaning there is nothing there. It works. You can get it to work. You have to be really careful not to have null pointer exceptions. The moment your function returns a string or null, the caller needs to realize, hey, the return type is string. I get something back. What do I have? Oh, it might be null, might not be a string. It says string over there, and I keep forgetting that. Okay, so I'm just pointing out that this example was really, a username, a string plus 2 sentinel values. In Java, a type plus 1 sentinel value. We often hodgepodge that one very frequently. That's a union type doesn't need to be just that. A union type can be more interesting, and I'll talk about some more when we come together in lecture and do some practice on these. But I have some different examples. I want to mention maybe a course result. Okay, so yeah, there's some course, and you ask the registrar, hey, what did the student get in iTech 120 or something like that? I might get back the grade, okay? I might get back the fact that the course is still in progress. They're taking it right now. I guess they could have gotten an incomplete. That's different than a grade. Okay, so that's a real answer plus 2 sentinels. Or I might get back the fact that, hey, they have not taken it, but they have registered to take it next semester. We're in the middle of registration, perhaps. Yeah, and I would want to know that. So really, yeah, I might get back. This would be a very eminently reasonable data type, union type with 4 variants. Either get me a number corresponding to the GPA grade, 2 sentinel values for incomplete, in progress, or a string describing which of the future semester is going to be. Okay, or one that I got from Dr. Oki, another type you might have. I have about like 8 different examples down here in the notes. A transaction. Here's a good union type that Dr. Oki uses in his language Ada. Ada, by the way, supports union data types. And some semesters he talks about that, some semesters he doesn't. But yeah, Ada supports union data types. And you can say, hey, I have a new type. And it's either a double or an int or an object that is a struct that's a string and 2 ints. Okay, where a double might mean a cash payment. An int might be a check number that was submitted or something like that, or a checking account number. A string and 2 ints might be the credit card transaction, the credit card number and its expiration date or something like that. Okay, so yeah, that's a piece of information I'd want to use in real life, and in Java it's kind of hard to get that all together. In Ada, certainly Ada is a typed language that lets you say, hey, I have a union type that I'm going to pass in a transaction, and the system knows at compile time it's going to be one of those 3 things. In an untyped language, unchecked, not a statically typed language, not untyped, a typed language that is not statically typed, dynamically I can return whatever value I want, and as long as me, the programmer, takes care of it, I can make sure, or I can go ahead and implement this. I might have errors that come up at runtime rather than compile time. The nice thing about Ada is, hey, if this is checked statically, I get my errors at compile time, rather than once I've run my tests, maybe I didn't test it well enough and something got through. Yeah. So, regardless, this is a union type. And I will close with why the term union. Do you remember our lecture from last time? I said, hey, we have some definitions about values and expressions and types. And I said, no, I'm going to say a type is a set of values. A set. And now we understand why OR makes a union type, why we call it a union type. Hey, I have the set of strings, union, the set of listed directory, where's my transaction? I have a set of doubles, union, a set of ints, union, a set of structs that are a string and 2 ints. That's the union of 3 other disjoint sets, and that new thing is a new set, a new type. Yeah. Okay. Sounds good. We'll look at some more examples in class when we come back. Thank you.